हाँ हाँ uh, good afternoon, students, and welcome to the live session of this NPTEL MOOCs course on biomass fractionation and biorefinery. I'm sure you must be enjoying the course till date. We have covered a good amount of syllabus. So as you know that we started the course with an introduction to world energy scenario, then why the fossil fuel is depleting, and the related environmental issues, and why there is a need for biomass based industries under a biorefinery concept. Then in the next module, we have discussed in 4 successive classes about the biomass in detail. So biomass availability, abundance, how photosynthesis happens, biomass composition, different types of biomass, including the waste biomass such as municipal, industrial, agriculture, forestry, their availability, their potential. Then second lecture, we have dealt with the biomass as energy resources. That means we discussed about the dedicated energy crops like maize, sorghum, sugar beet, hemp, then perennial crops like switchgrass, miscanthus, all these thumbs, and then poplar, willow, which are dedicated energy crops. Then in the next phase, we discussed about oil crops and including that of the microalgae and how oil can be harvested from algae and all these things. And then in the last class of this module, we discussed about enhancing biomass properties for biofuels and the challenges in conversion. Then we switched to biorefinery. So where I dealt with the biorefinery concepts, like different types of what is a biorefinery, how it is different from a traditional petroleum refinery, then types of biorefineries, then the biorefinery feedstocks, different types of feedstocks, not only limited to biomass, but other things also. Of course, whatever biomass we discussed, that plus other things also. And also what is an integrated biorefinery and how economics should be evaluated for a biorefinery, and what is the LCA, which stands for the life cycle assessment, which is one of the most important thing about any bio-based process industries. We need to go for a LCA study as well as a TEA study, that is the techno-economical evaluation study. Okay, now in the next phase, we'll be dealing with the pre-treatment, which is another very important factor of any biomass conversion. Because biomass here, if we talk about biomass here, basically let's say lignocellulosic biomass, then what happens? They have a recalcitrance in nature, right? They have a huge crystallinity, and lignocellulosic biomass basically consists of lignin plus cellulose plus hemicellulose, plus there are volatile matters and other matters. So basically 3 things, this lignin, cellulose, hemicellulose, they are very intricately bound to each other in a very tight fashion, right? So, but we need what? We need cellulose and hemicellulose for our conversion processes. So what we need to do is the pre-treatment. So pre-treatment is basically a delignification process, more or less you can say like that, wherein we remove lignin from cellulose and hemicellulose. And also, and please understand that lignin is a very high value component, okay, or chemical. So, and it has a lot of value addition. So we can use lignin for different purposes, of course, that we'll see later on also. And then different techniques of pre-treatment like dilute acid, alkali, autohydrolysis, ozone, different types of hybrid methods we have discussed. Then we started the physical and thermal conversion processes. Initially, we talked about gasification, pyrolysis, basics. Then every such lecture module is basically followed by a commercial success stories. Okay, so that you can understand how I have framed these lectures, so that everything that we study, there is a real life something is happening somewhere, not necessarily in India. Okay. Then we'll be going for microbial conversion process. I think these are going through where now it's going on, and fundamentals. And we also discussed about the equipments. This is another important aspect of this course, which is not covered in other courses, right? So where people never talk about different types of equipment. Now, equipment is very important part of any such biorefinery or biomass fractionation process development. So then one by one we are discussing the biorefinery products, starting from biodiesel, then bio-oil and biochar, which is essentially coming from the thermochemical conversion of biomass, which is pyrolysis. Then we'll talk about bioethanol and biobutanol. So these are very important fuels. More say bioethanol, because biobutanol, though it has more or let us say better fuel properties, but it has a lot of different issues. All right, most related to safety, then aesthetic issues like smell and all. It is a N-butane smells like a rotten banana actually, right? And so these are the issues which are still need to be addressed. So even though biobutanol is a better fuel in terms of the fuel properties than ethanol, ethanol is right now blended with the petrol. Okay. So then quickly we'll go to the next module, which will deal with the hydrogen, methane and methanol. Okay. Then organic commodity chemicals from biomass, which are basically called as platform chemicals. That will be discussing different types of acids. Like if I recall correctly, it's lactic acid, then PLA, polylactic acid, succinic acid, acetic acid, butyric acid, propionic acid, then PHA, 1,3-propanediol, all these things will be discussed. And in the last module, which is probably the module number 12, there are 3 classes that will be dedicated to integrated biorefinery. Okay, so we have discussed about what is biorefinery in our second or third module, I think third module. Then we'll discuss about finally the final module. We'll talk about the integrated biorefinery, where we'll see aquaculture and algae biorefinery, waste biorefinery, different types of hybrid chemical and biological conversion process, then followed by the techno-economic evaluation and life cycle assessment. So this is what I wanted to brief you about the entire course. I'm sure you people are attending, and many of you are doing assignments in time and all these things. So I shall be very happy to take queries. So please type the queries in the YouTube. I'll be answering you. Yeah, so Hari is asking that we need some clarification for assignment 4 that was given. I think we have already provided. I'll check with my TAs once again. Okay. So somebody, Raptor, is asking, is starting an algal, ethanol and biofuel production facility a viable venture, especially in Assam? I still have to catch up with the course since I started pretty late. Yes, why not? We are day and night working with algae. If you can come to IIT Guwahati, you can see we have a good algae biorefinery lab that we have developed, and where we are having 1,000 liters of algae culturing facility. My students are working on that. So of course, climatic condition wise, Assam is not excellent in algae production as parts of other South India or even western eastern part of India. But it is viable. It's not that it is not possible. Okay. Now, please understand one more important thing. As this course is especially talking about biorefinery. So biorefinery matlab kya hai? What is biorefinery? So biorefinery is basically one, if you take one feedstock, one product, this is one thing. Now that is not possible. That is why sustainable, basically not possible, not economically sustainable. That is why this concept of biorefinery has come, wherein we have multiple feedstocks and multiple products. Okay. Now let us say algae. Algae, we cannot have a 365 days algae production in a similar fashion. So that is why it is the need of the hour to integrate algae biomass along with other lignocellulosic biomass, municipal solid waste, organic waste, and to see how they can be valorized into value-added products. So basically, multiple feedstocks, multiple products. That is the most important thing. Someone is asking, what will be the pattern of questions paper in the final offline exam? Will it be objective? It's not offline exam, it is online exam actually. There will be mostly objective type and then subjective also will be there. Because this is a complete theory course where there is no chance of any numericals. So here we need to give some subjective questions and then multiple choice questions will be there. True and false type of question will also be there. Another question somebody is asking, I don't know from where, of course, how can one integrate this concept of biomass conversion and refinery into community development for advancing clean cooking? Now, the question is not very clear actually. Community development for clean cooking means what? What type of cooking? If it is a biomass based cooking, then we need to go for clean fuel stoves. Now, under MNRE, even IIT Guwahati and other institutes have designed very and good energy efficient clean biomass based cooking stoves. Okay, now those are already there in the market also. Few technology transfer has happened and you can see them in market also. Yeah, it is happening, it is there also already. Yes, Assam bamboo should be a viable option. There is no doubt about it. I don't know how many of you are aware that in Assam, in Numaligarh, the Numaligarh Refinery Limited (NRL) is establishing the first of its own kind state-of-the-art bioethanol plant. Okay, or a biorefinery, you can say, in the Numaligarh in their own campus. So it is about to be commissioned 1.5 years before. Due to pandemic, it could not be because they could not procure many of the machineries from the European countries. It is in collaboration with one of the Swiss company, and somehow I am associated with them, not directly as a consultant at all, but I know because we are doing some other projects with them related to this bioethanol plant, where they will be using this Assam bamboo to convert them to bioethanol, which will be then blended with the petrol. So many good things are happening in Assam and India in this sector. I'm sure there is a lot of opportunity for startups in this particular sector of bioethanol and bio-oil, pyrolysis oil, gasification pyrolysis sector, where you can produce biochar, which is having a huge potential in cosmetic industries as well as water treatment industries. Okay. I think since no more students are also online and there are no more queries, I think we can wind up closing this session today. So thank you very much to all of you who have joined. Thank you very much.